So next we're going to take a look at what can happen when we use industrial farming methods for harvesting fish. And this example I believe is from Miller. I'm not sure if this is in your textbook. So this graph represents the number of fish landings or the fish harvested in tons in Canada off of the North Atlantic coast. And this particular fish is the North Atlantic cod. And you can see that for many years the landings went up and down a little bit. There was some variation, but it was generally between 200,000 and 300,000 tons of fish. Then in the 1950s, there was a type of trawler invented that was called a bottom trawler, and it was able to harvest a lot more of the cod. So you can see immediately there was a sharp increase all the way up to harvesting as many as 800,000 tons of cod. So almost 4 times the usual amount of cod that was harvested. Now remember your S-shaped carrying capacity curve. If the fish are harvested below a level from which they can recover, that population will crash. And that's what happened here. The amount of population quickly dropped off, and so by the time you got to late 1970s, there was about 100,000 fish landings, or back to, almost not, definitely below the level that it had been. So then moving on, some protections were put in place, some limits as to how many fish could be harvested. However, the population was not able to rebound and eventually did crash. And in 2003, all fishing for this cod in these waters was banned. Now, fast forward to basically 2 decades later today, that population of cod for many, many years did not recover. And so some plans were put in place. Actually, they were put in place immediately back in about 2003 to protect the ecosystem so that the cod could recover. And they have recently found that one of the things that happened was that the cod were a predator, a top predator for eating some smaller fish called forage fish. And these forage fish forage on plankton. So once their predator, the cod, was removed, the forage fish populations exploded because they had no predator and they had plenty of food. And that went on until only just recently. And at this point, the forage fish overshot their carrying capacity the carrying capacity of this area for the forage fish, and they had a population decline. And their resulting population decline opened a window just large enough for some of the cod to start to rebound. One thing I forgot to mention about the forage fish is they also eat cod eggs and the young cod, so that further kept the cod population limited. But once these forage fish experienced a die-off, then it allowed a window to open for the cod to start to rebound. Now, they're still not considered a recovered population. They're still quite limited in numbers, but at least after several decades, they are seeing a response, a recovery. So that's one form of industrial farming of fish. We're going to look at something else that is called aquaculture. So growing the fish in specific regions, and that can be done very sustainably, or it may be done in ways that are not sustainable. So let's take a look at that. So first, the definition of aquaculture. Aqua means water, culture means growing. So aquaculture is the farming of aquatic organisms. It could be fish, shellfish, and even seaweed. And often it's done, let's say these are for fish, it's done where you have these netted off areas where the fish are contained, the fish can be fed, and therefore it's efficient and inexpensive. The fish are right there. You can feed them very easily. You can harvest them very easily. They are living in close quarters in this type of setup. So depending on the density of the particular aquaculture operation, antibiotics may be needed just like it is for chicken and beef. However, some operations, the density is kept low enough that that is not the situation. A potential issue with aquaculture, particularly this type, is pollution. Again, if you have high densities of fish in a particular area, they will produce higher amounts of waste, which will get into the surrounding water, say here and here, polluting it. Now, again, that depends on how the operation is done. There are operations where the water is flushed or the tide does the flushing for them, and the densities are kept low enough that the pollution doesn't exist because the nitrogen, etc., is spread around significantly. So a final issue or potential issue with aquaculture is the trophic pyramid. So remember, the trophic pyramid shows that as you move up the eating pyramid, the amount of energy that's transferred from one level to the next level up to the next level up, only 10% of that energy is transferred. 90% of the energy is lost. So this brings up the question of what is being grown in your particular aquaculture operation. So there are fish such as tilapia, which basically are very low on the trophic pyramid. They eat things like algae, and that actually just cleans the water more. And so if we then eat them from an aquaculture operation, there isn't a great deal of energy lost. Some aquaculture operations, though, grow things such as salmon. Salmon are top predators, right? They're high up on the trophic pyramid. And so to feed the salmon, it takes more and more energy to feed the salmon than the amount of food energy that you get out of them when they are ready for market. And so that is not an ideal situation. And the last issue, which I don't have on here, is that some people fear, depending on the variety, let's say, of salmon or whatever fish is grown, that variety may be well suited to an aquacultural operation, but not suited to survive in the wild. And so if these salmon were to escape the aquaculture operation and get into the wild, there's a potential for the species to be put at risk by having a variant that's not as suitable for the wild. I guess my last comment regarding aquaculture is that it does depend what country your particular farm existed. Some countries are known to have lax regulations, be very polluting, etc. However, if you purchase any fish that are from a United States aquaculture operation, they are regulated, and they are very much in sequence and sync, I guess is a better word, with environmental issues, and are not causing that. So if you have a choice, you should know what country you're purchasing from. Okay, just a quick review of the key concepts, but then I do want to go over the open response and add in a few more things about GMOs. So a couple of important terms to make sure you know and understand: tragedy of the commons, that there are different land management practices, and that regards regulations for both private and public land. Residential land use is expanding because of human population growth and economic factors, and that can lead to urban sprawl and urban blight. And then, even though there's just one bullet point here, all types of agricultural issues should be understood. Here's the potential open response question. What is genetic modification, also called genetic engineering? make sure that you don't say it's just the mixing of two different organisms. Make sure you include information about how a gene is inserted from one species DNA is inserted into the genetic material of another organism, usually a very different organism. Describe and give examples of two benefits of genetic modification. So there are quite a few in the book. I would like you to choose, when you describe the examples that you've chosen, be very specific. So for example, if I gave you, well, I'll go back to that, but be very specific, not just say bigger, better, faster. Say specifically what you mean by better, that higher food quality, which includes a certain vitamin, for example, and give the example of vitamin A in golden rice. Then describe two concerns about genetic modification. I provided several concerns. Be sure, again, to describe them. This one is a little trickier. How can a citizen of the United States know whether or not the food they are purchasing has been genetically modified? So I added in some information on the screencast about that. And I want to point out a couple more things that I think I may not have covered in enough detail to make sure that you're clear on. Most of your produce, as I mentioned, is not genetically modified. I'd like to give you an example of a new one that was approved for use in grocery stores and restaurants, and that's the Arctic apple. And as the name implies, it doesn't turn brown after it's cut. And you can see that would be an advantage, for example, for a cafeteria at a school producing lunches where they want to cut the apples, or maybe a restaurant. They can do that all in the morning and it won't be brown by the time the student or patron eats it. So some of these may not strictly be nutritional or quantity issues. For the most part, meat is not allowed to be genetically modified, but then not sold as food, though that is changing. The first thing that was approved was genetically modified salmon. And in this case, they inserted a gene, not from a bacteria in this case, but from a perch, which is a small fish. And what happens normally as salmon grow in size over time, they go through seasons, if you will, periods of times where they stop producing growth hormone and stop growing, and then they turn it back on again and start growing again. So this perch DNA tells the salmon DNA to not turn off the growth hormone production and just continue to grow faster and faster. So you can probably think of a number of reasons why that might be of concern. A further concern, the operations currently for the eggs, for the young salmon, are that it's done very differently than the aquaculture I just showed you. It's actually, they're begun in sort of like a giant fish tank. Let me put this on pause. Pardon the interruption. So they begin their lives in an indoor type tank, a tank that's separated from the natural environment, so almost like an aquarium. But then as they grow, they are sent to facilities that are in the water, and there is a concern again of escaping of genetically modified salmon into the wild population, which could potentially change the biodiversity if they can outcompete the natural salmon by outgrowing them and growing faster. So these are a number of issues to consider, and I think that's where we'll leave it. Let's see, do I have one more slide here? Yes. Okay, so later in the semester, we're going to pull together watching this video about America's food machine, and it also involves looking at energy and transportation, and it's we'll work together on that project once we've reached that point in the course.